Welcome, dear learners. Today we are going to discuss about the carrying capacity of the Earth. In earlier lectures, we have discussed various parameters of the population. Before proceeding into the lecture, I request to subscribe, like, and share the channel. Let's begin with the introduction. Carrying capacity is the maximum number of individuals a species can live in an environment without harming it. The concept comes from ecology and was first used to study animal populations, but it's equally important for humans and how we use Earth's resources. Understanding carrying capacity helps us to see the limits of population growth and why sustainable development is crucial. By knowing how many people our planet can support, we can plan resource use, food production, and environment protection effectively to ensure a balanced and thriving ecosystem. Now, let us explore what determines Earth's carrying capacity for humans. One key factor is resource availability. This includes food and water. We need enough crops, fresh water, fishery, and livestock to sustain populations. Another critical resource is energy, from fossil fuels to renewable sources like solar and wind, which powers our homes, industries, and transport. Lastly, raw materials such as minerals, timber, and other natural resources are essential for construction, technology, and manufacturing. The availability and sustainable management of these resources directly affect how many people our planet can support without degrading ecosystems. Environmental factors play a vital role in determining Earth's carrying capacity. Climate is crucial. Temperature, rainfall, and extreme weather events directly impact food production and human habitability. Ecosystem services are equally important. Things like pollination, soil fertility, cleaner air, and water purification support life and maintain ecosystem balance. Lastly, biodiversity ensures ecosystems are resilient and can recover from disturbances, sustaining human population over time. Protecting these environment factors is essential because without a healthy and balanced ecosystem, the Earth cannot support growing human population sustainably. Talking about technological advancements, technology has a powerful impact on Earth's carrying capacity. For example, innovations like green revolution, advanced irrigation systems, and renewable energy sources have increased food production and energy availability, allowing the planet to support more people. However, technology can also have downsides. Overuse or mismanagement, such as deforestation, pollution, and or exploitation of resources, can degrade ecosystems and reduce Earth's ability to sustain life. So, while technology can expand carrying capacity, it must be applied sustainably to ensure we don't harm the environment we depend on. Another key aspect is socio-economic and cultural factors. People with higher affluence and tend to use more resources per person, which can which can strain the environment. Lifestyle choices also matter. Urbanization, energy-intensive transportation, and diets with high in meal requirement, more land, water, and energy. Additionally, waste management is critical. Poor disposal and recycling practices reduce the effective carrying capacity by polluting land, water, and air. Together, these human behaviors significantly influence how many people the Earth can sustainably support, highlighting the need for responsible living and efficient resource use. Finally, pollution and environmental degradation, which significantly limits Earth's carrying capacity, air, water, and soil. Pollution directly reduces availability of clean resources needed for life. In addition, large-scale environment change like climate change, deforestation, and desertification degrade ecosystems and reduce the land's productivity, making it harder to support growing populations. These impacts not only threaten food and water supplies but also disrupt biodiversity and ecosystem services. Protecting the environment and reducing pollution are therefore essential to ensure that Earth can sustainably support human life for generations to come. Now, let us recap the earlier videos in which we discussed about various theories of the population growth, in which Malthusian theory, which was proposed in 1798 by Thomas Malthus, and he observed that the population tends to grow geometrically while food production only grows arithmetically. According to this idea, if population exceeds available food, it leads to overshooting, cause famine, disease, and increased mortality. While influential, this theory also has limitations. It does not account for the technological innovations like modern agriculture, irrigation, or food shortage that can expand the Earth's carrying capacity. Despite its criticism, the Malthusian perspective highlights the potential risk of unchecked population growth and importance of balanced human needs with resource availability. On the other hand is Boserup's hypothesis, proposed in 1965 by Esther Boserup. Unlike Malthus, Boserup argued the population growth can actually stimulate technological innovation. When human populations increase, pressure on resources rises, encouraging the development of more efficient agriculture practices, better irrigation system, and improved resource management. Another important model is I equivalent to PAT, that is, I stands for impact, P for population, A for affluence, and T for technology. This formula emphasizes that the environmental impact of humans is influenced not just by population size, but also by how wealthy people are and the technology they use. For example, high-tech societies may have large populations but lower per capita resource use due to energy efficient system, renewable energy, and sustainable practices. Finally, the carrying capacity model, for example, ecological footprint approach. This model measures the land and resource needed to support human consumption and to absorb resulting wastes. It gives us tangible way to understand how much Earth's capacity are using. Currently, the global ecological footprint exceeds the planet's biocapacity, meaning humanity is living in an overshoot, using more resources than Earth can sustainably provide. This approach highlights the importance of reducing consumption, improving efficiency, and adopting sustainable practices so that we can bring our ecological footprint within the planet's limits and maintain a balanced, healthy environment. Let's now look at human carrying capacity estimates. These estimates vary widely depending upon the lifestyle, technology, and how we use resources. For example, if everyone lived like modern Americans with high consumption, the Earth could support only about 2 billion people. On the other hand, with advanced technology and sustainable practices, estimates rise to 10 to 15 billion people. The key takeaway is that carrying capacity is not fixed. It is a dynamic and shaped by human behavior, innovation, and resource management. By adopting sustainable lifestyles and efficient technologies, we can expand the Earth's ability to support the life without degrading ecosystems. Next, let us discuss the factors that can cause overshoot when humanity exceeds Earth's carrying capacity. First, overpopulation. Too many people relative to available resource puts pressure on food, water, and energy. Second, overconsumption, especially of energy, food, and materials, increase resource strain. Third, environmental degradation like soil erosion, deforestation, and pollution reduces land and ecosystem productivity. Finally, climate change disrupts water availability, crop yields, and habitable areas. Together, these factors can push population beyond sustainable limits, highlighting the urgent need for responsible consumption, environmental protection, and policies that balance human needs with planet's capacity. Talking about the implications of sustainability, population control through family planning, education, and women's empowerment can reduce pressures on resources. Sustainable use like renewable energy, recycling, sustainable agriculture helps in maintaining ecological balance. Policy measures include environmental regulations, conservation initiatives, and smart urban planning ensures resources are managed responsibly. Additionally, global cooperation is essential as many resources like oceans and the atmosphere are shared across countries. Together, these strategies allow us to balance human needs with Earth's limits, ensuring that current and future generations can live sustainably on a healthy planet. Let's look at some illustrative examples of how humans influence Earth's carrying capacity. First, food production. The Green Revolution dramatically increased crop yield, allowing the planet to support more people. Second, urbanization. While concentrated populations increase demand of water and energy, cities can also use resources more efficiently per capita. Third, renewable energy. Solar and wind power provide sustainable energy without depleting the fossil fuels, supporting large populations. These examples show that through innovation planning and sustainable practices, humans can expand Earth's carrying capacity while minimizing environmental degradation and ensuring resources remain available for future generations. To wrap up, here are the key takeaways. Earth's carrying capacity is dynamic, shaped by resource, technology, and human behavior. Simply, increasing the population without consideration of the resource limits can strain ecosystems, but innovations and efficient technologies can temporarily expand capacity. However, relying solely on the innovation isn't enough. Sustainable practices like renewable energy, efficient agriculture, and responsible consumption are critical to prevent overshoot and environmental collapse. Ultimately, a balance between population, consumption, and technology is essential to maintain a resilient, healthy, and sustainable planet for current and future generations. Thank you for watching.